All right, I had a special request for this question, so let's go over it. It says in a clothing store, a jacket has a 17% chance of not having a label. It's an obscure percentage of it not having a label. Out of 11 randomly selected jackets, what is the probability that no more than 3 do not have a label? So they fit this criteria here. No more than 3. Express your answer as a decimal and round to the nearest hundredth. Well, first let's think a little bit about what this no more than 3 means. That means that we need to account for a few things. No more than 3 means a success would be that we get 0. It would be that we get 1 without a label, 2 without a label, and 3 without a label. And so to really do this accurately, we need to find out what the probability of getting 0 without a label is. What's the probability of getting 1 without a label? What's the probability of getting 2 without a label? What's the probability of getting 3 without a label? And then we need to add all those probabilities together because those are all different ways that we could successfully do this. Now, in order to pull that off, we need that formula that we got at the end of chapter 12. And it's called the probability, in your notes I called it probability with combinatorics. So this is like multiple events with only 2 outcomes. So we use it for like flipping a coin multiple times or a bunch of different things like that. Or, rolling a dice, but where I know there's only 2 outcomes, but we would say a dice has 6 outcomes, but if it was rolling a dice, we could say like, okay, 1 and 2 is success and everything else is a failure. So you just have successes and failures. And so just a little reminder of what that formula looks like. It's this thing. So the probability of an event is you do your success plus failures, choose just your successes. That's kind of like your coefficient. And then in here, you're going to do your probability of success to the number of successes that you want, times that by your probability of failures to the number of failures that you want. Okay, so there's our formula, and we're going to just do that each time here. So let's do the first one. The first one's 0. Okay, well, what's the probability that we get 0 with not having a label? Well, again, success plus failures, there are a total of 11 jackets. But out of those 11 jackets, we only want 0 of them to not have a label. All right, so 11 choose 0. Now, what's the probability of getting a success? Remember that they tell you right there, it's 17%. So the probability of successfully, in this case, the success is not having a label. That may be worth, success equals no label. That may be worth just kind of jotting down. So we're going to say 0.7. And how many times do we want that to happen? We want that to happen 0 times. And then we also need to account for the probability of having a label, which in this situation would be a failure. And so that would be 0.83. And how many times do we want it to have a label? Well, since it's not having a label 0 times, all 11 other times would have to have a label. And so we're going to use this same formula over and over again. And it's actually pretty simple. So now this is going to be 11, choose 1. The number inside these parentheses is always going to be the same over here for the probabilities. So this is 0.17 every time because this is your probability of success. And this is 0.83. And this is all going to be 11, 11. So 11 choose. So 11 choose 2, 2, 9. Oh, sorry, skip this one. 11 choose 1, 1, 10. 11 choose 2, 2, 9. 11 choose 3, 3, 8. And just a couple little things to point out. You'll notice these numbers always add up to 11, right? And that these two numbers will match, these two numbers will match, these two numbers will match, and these two numbers will match. Okay, just kind of like quick little show you how to set that up. So at this point, we need the calculator. So you're going to plug each one of these formulas into your calculator, and you're going to get some numbers. So let me do that real quick. First row into my calculator, I get 0.129. Now I'm going to round to the nearest thousandths because it does say that we're going to go to the hundredth later. But if I just go to the thousandth for now and then round to the hundredth, I should be pretty good. In fact, you could actually, might be better to go another 2 decimals out, but I'm going to be lazy for the sake of this video. Now, let's do the next line. When I plug that in, I get 0.290. That's a 9. if you plug the third row in here, you get 0.297. And on the last one, I get 0.183. And now, remember, we have to add up all of these probabilities. So if you add all these up, you get 0.899. But remember, we're going to round to the nearest hundredth, which would give me 0.90, which you could actually just write as 0.9. So there's a 90% chance that you would get a jacket that has no label, or that you get either 0, 1, 2, or 3 jackets that have no label. So out of 11 randomly select jackets, there's a 90% probability that no more than 3 do not have a label. I know it's a little bit crazy. It's kind of why it's the last question. It's kind of a doozy, but that's how you do that one. You got to do each of those calculations independently and then add them all up.